Okay, so intermediate value theorem. Before I actually get into like the nitty-gritty of what the actual theorem says in the math language, let's just draw a picture and talk about what it means, okay? So if I have a graph, just in the first quadrant we'll look at, okay? If I have a value on my x of a and b, so two x values, a and b, are going to have two y outputs on a function, right? So maybe like f of a, f of b. The intermediate value theorem says if I have a function that is continuous, so remember continuity means that we have a limit that exists, right? And that limit also equals the value at that point, okay? So that was continuity we talked about last class. So if I have a value at a and a value at b, and I know that my function is continuous, meaning that there's no removable or non-removable discontinuities, there must exist some c in between those two that has a y value that is also between f of a and f of b. So there's some point in here, and it has to be continuous, because if it's not continuous, I could have something like, you know, maybe I go here and up, but there's a jump discontinuity, right? So it would not work. So it has to be continuous on that function in order for there to be a value at f of c, okay? So in mathy definition, what does that mean? What does that look like? We have if f of x is continuous on the interval a to b, it doesn't necessarily have to be the entire function, but it has to be continuous on that interval, and our y values have to exist outside of our f of c value. But it could also be written the other way as well, okay? It could also be written like f of b is less than f of c, which is less than f of a. Okay, these are basically just two things showing, is my function, is it like increasing or is it decreasing, okay? But it has to be in between those two values, those two y outputs. Okay, if that exists, then there exists at least one value x equals c on our interval from a to b such that f of c exists. So that's the mathy definition, okay? The picture, I think, makes a little bit more sense in terms of, like, what does it actually mean, though? Yes? Hopefully?
Yeah, basically the A and B and then continue with them in between.
Right, exactly, okay? But there's two things we have to check. We have to check that it's continuous, and we have to show that f of c is in between those two values. So let's look at this in terms of some pictures here, okay? If I look at these two pictures, they're both the exact same. Okay. However, we are looking at different intervals in the question. So for the first question here, it says, is there a value of c? So is there like an x value on the interval from -5 to 2? -5 to 2 would be from your x values here to here, such that my f of c is equal to 2. F of c is your y value, right? So you're thinking, what is a y value of 2 in that interval? Is there a value with a y value of 2 in that interval?
Yeah.
Yes, it's right here, right? It's about, I don't know, in between -4 and -5 there. So yes, there is. C is in between -5 and -4. However, the first part of the definition for the intermediate value theorem says that it has to be continuous. Is this function continuous from -5 to 2? It is not continuous on that function, okay, on that area. So it says, does the intermediate value theorem guarantee a value of c such that f of c equals 2 on my interval? Why or why not? Well, no, because f is not continuous on our interval -5 to 2. Okay, in the second picture here, though, the second picture is asking us to look at a different interval. It's asking us to look from -1 to 5. Okay, is there a value when my y value is equal to 2 on that interval?
Yes.
Of 2 or -2?
Oh, 2.
It'd be -2, right? So there's no output of +2 on the y's. Yes, there is an x value of 2, but not a positive y value of 2. So this would be no, there is not, okay? And then it says, does the intermediate value theorem guarantee a value of c such that f of c is equal to 2 on our interval from -1 to 5? Why or why not? Well, it is continuous, right? So first thing that we do check is it is continuous on that interval from -1 to 5. So technically we could start by looking at this if we didn't have the graph when we were looking at just a function. The next thing we would need to do is check and see what is our value equal at these x values. So like what is f of -1 equal on my graph? F of -1, approximately, what do you think it is? Where's that cross? -0.5 or something like that? -1/2, we'll say. And then if I look at the function at 5, again, I'm looking at these 2 points because that's what my interval is looking at. So f of 5 is going to equal maybe down here at like -3.5. The intermediate value theorem says if our f of c value is in between these two values, then we can figure out what the c is equal to. Well, my f of c is equal to 2. Is 2 in between -1/2 and -3.5? No. Okay, so we can say, no, the intermediate value theorem does not guarantee a value because f of c is not in between f of a and f of b. Okay, that's kind of like that justification piece. You're explaining why, not just saying no. Why does it not work? Okay. All right, on the second page, we're going to list those 2 conditions again that we have to check. Okay, our first condition, in order for us to verify the able to use intermediate value theorem, is what? The function is continuous. Ooh, why did it get so large when I was writing? F of x is continuous on the interval a to b. And then we also have to have f of c is in between f of a and f of b. Okay, so we've got 5 examples. We're going to kind of go out of order here because I want to do one that shows you it does work to start and not show you one that doesn't work. Okay, so let's go ahead and skip to number 4. Okay, so number 4 here, we've got this function on this interval, and we know that f of c is equal to -1/2. okay? The first thing that we need to do is check to see, because also my instructions back at the beginning of this said, for each of the following functions, determine if it is applicable to use the intermediate value theorem, and then why or why not. If it is applicable, we need to find the value of c, okay? So, first thing that we need to look at is this function continuous on this interval? Well, when is the only time this function is not going to be continuous?
X equals 2.
At x equals 2, because on our denominator, right, there is a vertical asymptote there, right? So x at 2 is discontinuous. Does that matter in my interval? Is 2 in my interval? No. So I don't really care that it's discontinuous at 2. Okay, on my interval from -1 to 1, it is continuous. So we would say something like f is continuous on -1 to 1. That's like your first condition that you checked. Okay, second condition that I need to look at is, what are my functions equal at -1 and 1? So what does f of -1 equal? So I'm plugging in -1 into my function. So I get -1 over -1 minus 2. Okay, if I simplify that, -1 over -3, which equals just 1 over 3. Okay, just plugging in these values. I also need to check 1, f of 1. If I plug in 1, I get 1 over 1 minus 2, which would equal just -1. Okay, now the question we're asking ourselves is f of c equal to 1/2 in between these two? Oh, thank you, -1/2. Yes. Okay, is f of c equal -1/2 in between those two values? Yes, on our x, if we think about a number line here, we've got -1, we've got 1/3. Yes, obviously -1/2 is in between those two. Okay? So we can use, or we can say, therefore, those 3 dots, therefore, the intermediate value theorem exists. Or applies. Okay? So now that we've shown those two things are true, we need to actually find c. So what is the c value that gives me a y output of -1/2? Okay? So there's a few ways we can do this. We can do this by hand. We can do this with a calculator. I'm going to show you by hand first. I will show you by calculator on problem number 3. So when I'm looking at this, I am looking at when is my function equal to -1/2. So if I'm solving for x, I'm just going to set this -1/2 equal to the right-hand side of my equation. So -1 over 2 is equal to x divided by x minus 2. Okay? Can you guys solve that? All right, go ahead and solve that for me. Okay, did we all get x to be 2/3? Yes? Okay, so our x is actually, we were solving for c, right? My f of c is equal to -1/2. So my c value is 2/3. Okay. So if this was actually a graph here, pretend there's a line there, right? At -1, our function is at 1/3. At +1, our function is at -1. So at, wait, yes. Yes. And then at 2/3, my function is at 1/2, right? So kind of a poor picture here, but you get the idea of our function being continuous there. So we have a point in between those two where our c value is 2/3, which gives us a c, or a y output of -1/2. -1/2, not 1/2, so it should be down below. My bad. Ignore that one. It would be down here. Okay? Sorry about that. Okay, let's look at number 5 next. Okay, number 5. I've got this function. This -2 is part of the function, so it's -2 there. Okay, and we are solving this on the interval from 3 to 5. for f of c is equal to -4. So we got to check and see, is our intermediate value theorem, are we going to be able to use this? First thing we got to check, is this continuous on the interval from 3 to 5? If it's an exponential, continuous, right? I can have negative values in there and I'm going to get outputs. So it is continuous. There is no horizontal asymptote, or not horizontal, there's no vertical asymptote, right? Because there's no denominator there that we set equal to 0. So it is continuous on the interval from 3 to 5. Next thing we need to do is we need to check, what is the function equal at 3? What is it equal at 5? So f of 3 equals f of 5 equals. Okay. This is a problem that you could do without a calculator. Okay, so just be careful when you're plugging it in. This negative is not included in the parentheses, so it's -1/2. So then -3 plus 3. And then that whole thing is -2. So that would give me 1/2 to the 0 power. Anything to the 0 power is what? 1. So I'd have -1 minus 2, which gives me -3. Okay, when I plug in 5, some of us struggled last period with this. When I plug in 5, it's -5 plus 3. That whole thing minus 2. Well, if I simplify those exponents, I get -5 plus 3 is -2. So I get -1/2 to the -2nd power. Remember what happens if you have a negative exponent. If I have like a to the -2nd, that would become 1 over a squared, right? But if I have a fraction, if it's like 1 over a to the -2nd power, this becomes a to the 2nd power, because it's like a over 1. Do you guys remember that from algebra? Good. Okay, so if I was evaluating this, I would have -2, right, to the 2nd power. Using that negative exponent there, it changes this to -2 squared minus 2. Notice this -2 is not in parentheses, right? So it's going to give us a different answer if it was in parentheses. So when I evaluate this, I get -6. Okay, because -2 squared would be 4, -4, and then -2 is -6.
What? Oh, non-parentheses.
Yep, non-parentheses. Gotcha. Okay. All right, so we need to look and see, is my f of c value, so does f of c equal -4 exist in between those two numbers? Does -4 exist in between -3 and -6?
Yeah.
Yes, it does. So we can go ahead and say that the intermediate value theorem applies. So therefore, intermediate value theorem applies. So we need to solve for what is c. Okay, and we can say it applies because our f of c, which is -4, is in between f of 3 and f of 5. Okay, so just like we did on the last one, if I'm solving to figure out when is my y value, or when is my x value, no, I'm plugging in the y value, which is -4, right? And I'm trying to figure out when is it equal -4 at what x value, okay? So we're solving this equation. We're solving -4 is equal to -1/2 to the -x plus 3 minus 2. Okay, I want to figure out when is my y output going to be -4. What is my x value when that happens? Okay, I'm going to let you guys sit here for a second, try solving this, and see how far you get. So we should have gotten, after you solve this, that x equals 4. If you need help with that, make sure you come see me and I'll show you. But that means our c value is actually 4, right? That's what we solved for, because my f of c value gives me that -4. So this is when my y output is -4. Okay. Think c is like your x, f of c is like your y's. Yes? Okay. All right, now let's go back to page 2 and go over problems 1, 2, and 3. So problem number 1 here. Okay, same thing. We're doing the exact same thing. Is this function continuous is what we have to check first. And then also, is f of a and f of b, is f of c in between those two, okay? When is this function, better question, not continuous? At -2, right? So at x equals -2, f of x is discontinuous. Okay. Is -2 in my interval?
Yeah, no.
Wait, no.
No, right? -1 to 3 on my x's is not including -2. So the rest of the function is continuous from -1 to 3. So we would say f of x is continuous from -1 to 3. Okay, so I want you guys to check two things. What is f of 1 equal, -1, f of -1, and what does f of 3 equal, okay? I'm plugging in the values from my interval to see what is my y output going to be. Okay, so plug those two values in, see what are you going to get for f of -1 and f of 3. All right, did we all get -4 and 0 when we plug that in?
Yeah.
Yes? Okay, we got to check and see. Is f of c, which they told us is 2/3, is that in between -4 and 0?
No.
It is not, okay? Right? 2/3 is not in between 0 and -4. Right? If we think about my x values, yes, it's in between my x values, but I care about my y values here because this is f of c. So these are the functions that I'm looking at. Is it in between? Okay, does that make sense? Okay, so we would say here that, therefore, the intermediate value theorem does not apply. Because, again, that justification piece to get you, if you're taking that AP test, to get you that extra point, right? So you get the full credit on this question. We want to say because f of a, or I should probably say -1, okay? F of c, which equals 2/3, and f of 3 is not true. Okay? Or if you'd rather just write that out in words, you could just say because f of c does not exist in between f of -1 and f of 3, if you'd rather do it in words, okay? All right, and then number 2 here. Number 2 is the exact same question except for what's different? The interval, okay? So the same thing happens, right? On this function at -2, it is discontinuous. So since now our interval is different, is this function continuous on the interval from -4 to 1? No. So we can go ahead and say, therefore, the intermediate value theorem does not apply. Because our function is not continuous. All right, so number 3 here, I've got a function, and I've got an exponential times cosine of x on this interval, and my p of c function is equal to 5, okay? So we need to see, does that exist with my intermediate value theorem? So, is this function continuous first off? Yes or no? Yes, it is, okay? There's no dividing by anything or anything like that, so this function is continuous. So we would say p of x is continuous on the interval from -2 to 1. Okay, next thing we have to check, is my function p of -2, figure out what does that equal, and p of 1. We have to figure out what that equals. Now there's a few different ways that you can do that. You can either just in your main calculator screen, right, go ahead and type in e to the -2 plus 2 cosine of -2, okay? Or what we could do instead is graph it, and then figure out what the value is at that point. Okay, yes.
I want to leave the screen.
Oh, to leave the polyroot finder, go ahead and hit second. Yes, to quit, yes. And then go back second mode again to quit out of it again. Yeah, there you go.
Thank you.
So on your graphing calculator, really quick, I want you to graph under your y equals e to the x plus 2 times the cosine of x. So mode is in radians. Okay? So after you've graphed that, now we can find the values at -2 and 1 by clicking on a few buttons, okay? To figure out what it equals at -2, you hit second trace. And my calculator froze. And then you're going to choose value. And then you can just type in the value that you want to figure out what it equals. So type in -2 and hit enter. And we should get our output of -0.416. Did you get -0.416? Yes. Okay, then we can do the same thing. Type in 1, hit enter, and we should get 10.852 on our calculator. So then we have to ask ourselves the question of, does f of c exist in between those two numbers? Because p of c technically, p of c is equal to 5, right? 5 exists in between those two numbers of my y outputs. So we know that the intermediate value theorem exists. Or we can apply it. Okay? Because P of C is in between P of -2 and P of 1. Okay, so then what I actually really care about is the equation that we would solve here, which is why we're not solving it by hand because it's going to be really gross, is the equation 5 equals e to the x plus 2 cosine of x. Okay, we cannot do that. So we're going to use our calculator. Okay? In our calculator, we already have this function graphed. Yes? Okay. In y2, I want you to graph 5. This will be y1. Y2 is just 5. That's it. Only 5. And then you'll hit graph. Okay, when you hit graph, your function probably looks something like this. Terrible drawing, but you get the idea. And there's a line that goes through it, yes? Okay. Now, what we care about is when is this crossing, or when is this red and this blue line crossing on the interval from -2 to 1, okay? Which is actually only going to be 1 point. Even though it looks like it crosses through a bunch, it does, but I only care about the interval from -2 to 1. So we are going to change our window, okay? Change our window on our graphing calculator to be x minimum of just below -2, like -2.01. And our x maximum, let's have that be just a little bit above 1, so like 1.01, okay? So if you change your window, it'll be a little bit easier to see what happens. But then to make it even nicer, choose the function zoom, and then I think it's like option 0, or it says fit, okay? What that's going to do is it's going to take your window from -2 to 1, and it's going to zoom in on your y values for you. So you don't have to figure out, okay, where is it going to be? Do I need to up my y values or make my y values smaller? It'll just fit it for you in your screen, okay? So do we all have, well, let me see here, -2.01, 1.01. So when you graph it with the zoom fit function, we should see something that looks now like this. Mostly just the top left quadrant. So it looks like this, kind of goes up, and then we've got a line going through at 5. And it looks like it crosses on the y-axis. It actually doesn't. I kind of drew that poorly. But this is just on the outside, right? So I need to figure out where is it crossing there, okay? Because where that crosses is my c value that makes my y value 5, okay? Anyone know how to do the intersection function on your calculator? Okay, that's what we're going to do. We're going to use the intersection function on our calculator. So to get there, you're going to hit second trace, option 5, or option to intersect. It might be different on yours. Okay, and then it's going to say something like first curve.
At this time,
Okay, so you'll go with your left and right arrows until it's just below the curve here, and you'll hit enter. Okay, then it's going to jump to the second curve, which is your second line, right? Because you're figuring out when is it intersecting those two things. So then you can just hit enter again. You might have to use your left and right arrow a little bit, but you hit enter, and then it's going to say guess. Okay, so it said first curve, second curve. You have to hit enter after each of those, and then you can hit guess, enter.
It doesn't ask me for guess, it asks me for lower and upper bound.
It might say lower and upper bound on yours too, and that's okay. So on your graphing calculator, you should have gotten negative 0.334, right? Comma 5, bless you, is your answer there, okay? Now, the answer that we were solving for is C. So C is which one of those two? The X, right? So my C value is negative 0.334 from our calculator. Okay. Oops. Like negative, look here at this question. I've got a bunch of different values. On AP Classroom, you guys have access to videos, yes? To see, maybe? So this is from one of the videos. He goes over a question that's very similar to one of the questions that are on AP Classroom. Look at this question here, okay? It says that we've got a selected range of values on a continuous function. Continuous is important because then that allows us to use the intermediate value theorem, right? So again, knowing the definition of what a continuous function is and how that helps us is important. And then it says, what is the fewest number of zeros of f in the interval from 20 to 30? So these are all of your x values. These are all of your y values. So you can think of writing these all as points, like 20, 2, 22, 1, okay, et cetera, et cetera. What is a zero? You guys have heard that word before. What do you mean by solution?
It's when the function crosses the x-axis.
It's when the function crosses the x-axis. So if I look at a graph here, right, and I had like a function just like an x squared, right, my zeros are where they cross the x-axis, okay? So in this case, there are 2 zeros for this function, okay? In this function, we have no idea what this graph looks like, but we do know something about the points. Okay, a zero happens when we go from a positive to a negative on a graph, or a negative to a positive, right? Because right here I've got a positive y value, then I go to a negative, which means I have to cross the x-axis at some point, crossing 0, okay? So really what you're doing is you're looking at, okay, when is there a sign change, right? And if you looked at this question, you had no idea, read the options, because I bet just the options are probably going to help you out too. But if I look here, 1 and negative 3, my outputs, right? If I were thinking about graphing this, it would be like at 22, 1 and 24, negative 3. Well, if it's continuous, it's going to have to cross at some point, right? So we know that there's going to be 1. Where else is there going to be another one?
28 to 30.
28 to 30, right? Because it goes from 28, negative 3, so like further, negative 3, to 30, 1. So again, if it's continuous, it's going to have to cross the x-axis at some point. So what's my answer going to be for this one?
C.
C. Yes. Sorry, I thought there was 2 options there for 2. But yes, letter C would be your answer for this one. Okay? Does that kind of make sense?